I'm going to discuss something about motion in one dimension. Topic in science, class 9 science, physics. But before that, let me introduce myself. Myself, Monica Gupta. I am taking 9, 10 science and 11, 12 science subjects past 14, 15 years. And today, with you all, I'm going to discuss a very small topic of motion in one dimension. So let us start that. So, what do we mean by motion in one dimension? Means that today's topic that I'm going to discuss today is motion in one dimension. So, before starting the topic, let us discuss what we are going to study motion. So, this term motion is very much related in our everyday life. It also means movement. Now, we say we move one place to another, we are moving to school, we are moving to home. Very oftenly, we are using this term movement. But do we know the scientific meaning? I must say no. We don't know the scientific meaning. So, what is a motion? Motion is considered to be a movement, or an object will be considered in motion, be considered at motion only in one condition. There should be a scientific meaning. When object, object can be anything, a vehicle, a human being, animal, anything. When an object surrounding or position is changing with change in time, means when any object surrounding is being changed with time, it is considered to be in motion, and that to be no, that it is in motion. There are many examples related to it. For example, if this is the sun and this is the orbit in which Earth rotates. Each and every second or each and every fraction of second, Earth is moving to its surrounding. It's continuously changing with the time. So this revolution of Earth is considered to be motion. Now, if it is Earth and this is the orbit of the moon is in continuous motion because its surrounding is changing with time. Earth is also rotating on its own axis. Continuously it is rotating. But do we consider this rotation as motion? Around this axis, it is rotating at a specific point like this. So, can we consider it? Think of few more examples we can discuss. We are sitting in a train in a compartment. Our surrounding is train compartment, and suddenly train started to move. So, can we say that we are in motion? The answer will be absolutely no. Why? Because our surrounding is train compartment, and train surrounding is continuously changing with that is train in motion. We have oftenly seen the railway tracks. When we see outside the train in which we are sitting and the train is moving, we consider the track is also moving along with us. Sometimes it happens. Just think, imagine that we are sitting in a train and we are looking up outside from the window and we are able to see the railway track outside. So we just think that railway track is moving along with us. But actually, no. Railway track is fixed at position. It is not moving. We are moving. And as we are moving, so we think that railway track is consistently along with us. Means wherever we are observing, railway track is present. So we just, it is, you can say, a hypothetical phenomena in which we observe that yes, we seems to be railway track moving, but actually we are moving. Our surrounding is changed, but in our surrounding, railway track is present permanently along with the change in surrounding. So this is also a kind of motion. Now let us discuss next heading, next part of the one means single and dimension means direction. So motion in a particular direction that we are going to discuss in this chapter. But before that, we should understand more terms like distance. So what is a distance? Distance means the length of the pathway. The length of the pathway covered by the moving object. So the total length of the pathway covered by the moving object. For example, the object started its journey from A, reached to B, then moved to C, then moved to D. So this total length AB plus BC plus CD is the total distance covered. It is simply the total length of the pathway covered from initial position to final position is known as distance. And coming to next, displacement. That is also very important point to be understood. It is in short considered to be the shortest distance. Or to understand, we should know that it is the length of the pathway between initial position and final. It is always being taken in a straight line. It cannot be twisted or zigzag way. It has always been considered in a straight line. For example, we discussed this example, we will discuss again. That object started his journey from A, then moved to B, then moved to C, and then D. So this is initial position, this is final position. So what is displacement? Displacement is AB. The difference between the initial and final position is displacement. It does not mean AB, BC, and CD doesn't matter. It's the straight away distance between the straight pathway present between initial and final position that we understand by displacement. So in case the object starts from A, then B, then C, then D, and again back to A. So is there any difference between initial and final position? The answer is no. There is no difference. Initial position and final position is A itself. So here displacement is 0. In a circular pathway, displacement will be 0 because initial and final position is same. But distance will not be 0. Distance will be circumference of IR. Here, distance will not be 0 because total distance will be AB plus BC plus CD and plus AD. That is the total displacement. So let us move ahead with the chapter that motion in one dimension. Suppose the object started its journey at 0 seconds. Then after 5 minutes, it covered 10 kilometers. Then after 5 minutes, it covered 20 kilometers. Then 30. Means time interval is 10 seconds. In each 10 seconds, object is covering this distance. So object started its journey from O, then reached to point A, then reached to point B. So this is the total length of the pathway, OB. And we are observing OA and AB, the total distance. And it has been considered in a straight line, means direction is not being changed. Object is moving in a straight direction. So object is moving in a straight direction. So here we can say the total distance is OB. Initial position is O, final position is B. So displacement is also OB. So when object is moving in a straight line in one direction, it is considered to be motion in one dimension. This is motion in one dimension. Object is not changing its direction. And in this case, distance and displacement is 0. Now, let us understand more about it by seeing a small video. By seeing a small video based on what we have discussed. So let us proceed that. So here is the small video explanation what I have discussed just now based on motion, distance and displacement. So let us observe it.
In earlier grades, we have studied motion and its types. Let's have a quick review. Let's start with motion. In simple words, if a body is moving, it's described as motion. That's all. In slightly more technical words, motion is defined as a change in the position of a body with time. Yes, change in the position with time. For example, when an object is moving from point A to point B, it's changing its position with time. We saw that the time is also changing along with the position. So it is undergoing motion. What are the types of motion that we had studied previously? We have seen 4 types of motion. The simplest of all is the rectilinear motion. It is the motion of a body in a straight line. The example that we saw earlier is of a rectilinear motion. Object is moving in a straight line from A to B. There is another type of motion called the circular motion. What can this type of motion be? It is the motion of a body along the circumference of a circle. Example: motion of the earth around the sun is an example of circular motion. The third type of motion that we saw is a rotational motion. It is the motion of a body around a fixed axis which is passing through the object. This is important. The axis has to pass through the object. Example of rotational motion is a ceiling fan rotating along its axle. So you see that if I draw a hypothetical line called the axis of rotation, then it's passing through the fan. And the final type of motion is a periodic motion, which is the motion that repeats itself in equal intervals of time. Can you think of any example of this type of motion? Any object repeating its motion in equal intervals of time will be undergoing periodic motion. Assume an object is moving in circles and is covering each round every 3 seconds. Is it performing a periodic motion? Absolutely. Since it's repeating its motion along the same path every 3 seconds, it is undergoing periodic motion. But wait a moment. This object is moving along the circumference of a circle. So it is also undergoing circular motion. So what can you conclude from this example? We can say that an object can undergo more than one type of motion at the same time. Here are the few of the examples of motion in our everyday life. Go through them well and tell me what type of motion each one of them represents. And note that one example could also have more than one type of motion. The first one is clearly rectilinear motion. It's a car moving along a straight line. The second one is interesting. Most of us would have guessed rectilinear motion after seeing the word straight. Which type of motion are the wheels of an automobile performing? Are they undergoing rotational motion or rectilinear motion, or both? Since the automobile is moving in a straight line, its wheels are undergoing both rectilinear and rotational motion at the same time. What about the simple pendulum? We know that a simple pendulum performs to and fro motion. This to and fro motion repeats itself in equal intervals of time. So it's undergoing periodic motion. Now let me ask you a question. Suppose you want to travel to city B from city A. Which mode of transport will get you quicker to the destination? A bicycle or an aeroplane? Obviously, an aeroplane. Because the speed of an aeroplane in air is much quicker than the speed of a bicycle on a road. But what is speed? Keep watching our videos to know more.
So here was a short description upon motion and types of motion. that we have seen, in all the cases, the object position was continuously changing, whether periodic, rectilinear, and others. So here, let us discuss motion in a straight line. So what is the motion in one dimension that I have discussed? Here will be a simple three-dimensional video based on it.
Say Ben wants to move this table from point A to point B. What will he do? Yes, he will push it in the direction of point B. You see that as he pushes the table, it starts moving. Anything around us that moves, we say that it's in motion. So this table is in motion. And since Ben is also moving along with the table, he is also in motion. In our day-to-day life, we see various things moving around us. Simple examples that I can give are vehicles moving on the road, people walking across streets, birds flying in the sky, and so on. Do you know that the Earth and the other planets also undergo motion? Yes, they are revolving around the sun. You can give me thousands of such examples of motion. But what if I ask you to tell me the definition of motion? How can we define something as intuitive as motion of a body? Well, for that, we need to look at what exactly happens to a body when it's in motion. Let's say this vehicle moves from point A to point B. You see that as it's moving towards B, its position in space changes with time. Initially it was here, then here, and now after some time it's here. Notice what's changing. The position of the object and the time too, which is changing anyway. The change in position of a body with time is what we call motion in simple words. Whenever there's a change in position of a body, we say it's either undergoing motion or has undergone motion. Let's discuss about the different types of motion now. The simplest type of motion is called the rectilinear motion. Notice that there is a word line in there. So we define this type of motion as a motion in a straight line. Yes, rectilinear motion is nothing but motion in a straight line. So if an object is moving along this straight line path, we say that it's performing rectilinear motion. For example, when a car is moving in a straight line on a straight road, it's performing rectilinear motion. There is one more thing that I want to discuss with you in this video. Assume you're on a railway platform watching the train pass by. You are at rest. For you, both the train as well as the passengers sitting inside are in motion. But will the people sitting inside the train say the same about the other passengers in the train? For a person sitting inside, the people in the train are not moving. They are at rest. So for the observer at rest on the platform, the people inside the train are moving, but for the person sitting inside, they are at rest. What does this tell us? This means that the motion of any object is relative to the observer. For different observers, the motion may be different. We will learn more about this in higher grades. In this video, we understood the definition of motion. We also discussed one of the types of motion called rectilinear motion. In the next video, we will see a few other types of motion.
So fine, we have discussed more about here motion and distance displacement that we have seen. More about motion like uniform motion, non-uniform motion, speed, displacement, that all things we are going to discuss in our next video. Thank you.